Hi, it's Mrs. Bokerman. Today, this video is going to teach you how to do partial fraction decomposition. So the first thing we want to talk about is you all know how to do a problem like this. If we ask you to add two rational expressions together, essentially fractions, when you're adding fractions, you need common denominators. And so what you would do is you would multiply this side by x plus x minus 4, and you would multiply this fraction by x plus 3, or the whole thing. It really doesn't matter. But you're able to do that. And once you do that, then you just kind of combine like terms. And so you already know how to do that. And if you were to spend the time doing that, you should end up with 5x plus 1 over x squared minus x minus 12, if you were to actually multiply out x plus 3 and x minus 4. So what partial fraction decomposition is instead, we are going to give you this 5x plus 1 over some quadratic, and your job is to come up with what it was before it got simplified. So it's breaking it into its partial fractions, hence the name. So you're decomposing it from it in its simplest form back to its fractions. Okay, so what you're going to want to do is think about it. It's the process of starting with a simplified answer and taking it part back or decomposing it into its initial polynomial fractions. Okay, so this video is going to deal with non-repeated linear factors, and the other video is going to deal with when you have repeated factors. So what does that mean? That means in the denominator, we're always looking at the denominators, you have a linear term. So in this first example, we have an x and an x plus 3. In the second example, we have an x, an x plus 1, and an x plus 3. Like, it doesn't matter how many you have, each one would be broken apart. Okay, so the process is slightly different if you have a repeated term, which we'll get into in the next video. So here are the steps for doing that. You might want to pause it and write it down. The first step is you need to factor the denominator if possible, or if it isn't factored. Once you factor it, you're going to actually create two different fractions, or 3 or 4, depending on how many factors you have in the denominator. And then above it, you're going to write a random arbitrary letter, such as A, B, C, D, etc., until you run out of factors. Then you're going to pretend that those are your new problem that we gave you, and you're going to simplify it. Okay, you're actually going to get common denominators and start the process like we did on the warm-up. So you would do this by doing a system of equations, or you can use your graphing calculator with matrices to solve that system. You're going to solve the system and come up with an answer, and then the final step is to actually write it in its decomposed form. Okay, so I'll show you how to do that with our first example, which is the same as the warm-up, so we already know the answer, but regardless, this is how we would do it. So you start with the original, and the first step is you got to factor the bottom, if possible. So I factored it into x minus 4 and x plus 3. The order in which you factor it does not matter, so that's irrelevant. What you're going to do next is I'm going to break it apart. So I'm going to say that the first factor, which is x minus 4, I'm going to say it's over some a. I'm trying to figure out what number goes up there. And the second factor, whatever it may be, x plus 3, is over b. Okay? And what we know is that this has to equal the original. Okay? So then what I'm going to do is pretend I don't have the original, and if I wanted on the right side to get common denominators, I would multiply by the denominator. So essentially, this a needs x plus 3, and the b needs x minus 4. Okay? So that looks like this. Okay, so a gets multiplied by x plus 3, and b gets multiplied by x plus 4. Now, because the denominators are the same, and it's the same on the left and the right, you can kind of ignore the denominators, because if you have an equal sign, that means everything on the bottom has to be the same and everything on the top has to be the same. Well, the bottom is already the same. So now everything on the top has to be the same. So here's what it simplifies into. Okay, now there's two different methods to go from here. I'm going to show you method 1 and then method 2. You pick which one you like. It doesn't matter. So method 1 is going to be, okay, if I'm going to stop here and I'm going to let x equals -3. Now, I didn't just randomly pick that number. I picked that number because if you look here, I could make this a -3, and then this whole thing would be 0. Okay, and I'm also going to pick 4 because if I pick 4 and put a 4 here, then that side would equal 0. Okay, so it makes it a little bit easier to solve. All right, so if I let x be -3, then I'm going to plug in a -3 everywhere I see an x. So I'm doing 5 times -3 plus 1, which gives me -14. Here, this whole a part is gone. And then this is -3 minus 4 is -7, so -7b. So now if I just divide, b is 2. That works. Similarly, I can do the same thing with x is 4. And so if I plugged in 4, 5 times 4 is 20, plus 1 is 21. This b would go away, and then a would be 4 plus 3 is 7, divide, a is 3. And this is what you got, okay? This is your final answer. You have to replace the a with the number and replace b with the number, which this is exactly what we got from the warm-up. Okay, method 2 actually takes it a step farther. Okay, so I'm going to go back to what we had. Method 2 is where I'm actually going to distribute my a to both things and distribute my b to both things. And then if I do that, I have this. So here's where the system is coming into play. This first line is all the x's, and this second line is all the constants. I'm going to write C for constants. So if you look at this, 5x, this 5x's has to be equal to the ax's and the bx's, because if you were to combine like terms, that's how you would end up with 5 of them. Similarly, this one over here has to equal 3a's minus 4b. So a certain combination of what times a and what times b would give you 1. So this is that system that you got. And these aren't hard systems. You can easily, if you remember how to do systems on your graphing calculator, you could go to a second matrix and type in 1, 1, 5, 3, -4, 1. And then when you're solving it, you would do the RREF, row reduced echelon form. Or if you wanted to do this one by hand, these are really not that complicated algebra ones. I would probably get rid of the b by multiplying by 4, the top row by 4. And again, you get 21 equals 7a. Shocking, that's kind of what we had before. A is 3 and then b is 2. Either way, your final answer is this in purple right here, where you have to write it in a decomposed form. So let's try one where we don't know what the answer is. So if we started with this problem over here, 6x plus 2 and x squared minus x minus 6, the first step is to factor it. So I factored it into x minus 3 and x plus 2. Again, the order in which you factor it does not matter. You'd get the same thing. And so I'm going to put a over x minus 3. I'm going to put b over x plus 2. Let's say there was a third one, like x plus 1. Then you would just have a c over that one and a d, however many linear terms you have on the bottom. Okay? So then what I'm going to do is I'm going to multiply, get common denominators. So my a needs x plus 2 and my b needs x minus 3. And then what that means is I have the top of the left side, 6x plus 2, equaling ax plus 2 plus bx minus 3. So here's method 1. Method 1 is I'm going to randomly pick some x's to just plug into this system. So if I was looking at a, I would want to make it -2. And if I was looking at b, I would want to make it +3. So let's do that. Okay. A is -2, or x is -2. So then if I plug it into the left side, 6 times -2 is -12 plus 2, -10. And then this would give me -2 minus 3, which is -5. Divide, you get +2. And then if I plug in 3, then the b would go away. 6 times 3, 18, plus 2 is 20, and times 5, divide, you get 4. So the final answer is I have to put the a in the right spot. So a was 4, so that goes over the x minus 3, and b was 2, so that goes over the x plus 2. So if you had it the other way around where a was over x plus 2, you still would have came up with an a being 2 and a b being 4. Regardless, it doesn't matter as long as you're putting the right number over the right denominator. Okay, if you went with method 2, you would distribute A, and then you would come up with a system. So the system would be, remember, my x's have to be the same. So here's 6x, here's an ax, and here's a bx. So I have 6 equaling 1a plus 1b. And then I would have 2 equaling 2a minus 3b. There's my system. And then you could use a graphing calculator with row reduced echelon form to solve and matrices, or you could just simply solve it by hand. It wouldn't take you that long. Either way, you end up with the same answer, whether you do method 1 or method 2, and that's it. Okay, so I would like you to try this last one on your own. Please pause the video, and then in a second, I'm going to show you the answer. So notice I have some fractions now. See if you can figure this one out. Okay, pause the video. Okay, I'm going to quickly show you the answer. You could pause it if you need a little bit longer to stare at it. This is how I factored it, multiplied. I'm showing you method 1, and I'm showing you method 2 in a second. Now, notice you get negative 0.75 and 0.5, okay? That's fine if you were doing it on paper, but Math Excel is going to want you to put it in as a fraction on top. So just so you know, Math Excel is going to want you to put the fraction on top. All right. Now, what's interesting is we got B to be negative. So here's how you could write the answer. You could put the negative up here, or you could change it so in the middle, you're actually subtracting instead of adding. So that's why we always choose the plus sign in between, so that it doesn't matter. The math will lead you if it was a subtraction problem originally. If you did method 2, here's the system that you should have generated. And then again, if you solved it, you would have gotten the same answer. And so you can put the answer on top. Okay, let us know if you have any questions. Good luck.